Oh my gosh, I gotta re-enter that shit. We have 0 viewers right now. Let's see. Yeah. Yeah, there we go. So 0 viewers. Whatever. Oh, 1 viewer. Okay, cool. All right, can you pull up the?
Yeah, it's on there. It's on the scroll. It's right there.
Oh, I didn't know this was a thing. Alrighty, so I'm Hafiz, and this is Coda, and
Hi.
we're going to be teaching Math Lesson 1, Introduction to Geometry. So let's get started. So let's talk about basics. Geometric notation. The SAT uses geometric notation, which is just fancy words for standard symbols and terms used to describe different things in order to describe lines, rays, points, angles, etc. Geometric notation is sometimes not covered in high school geometry, so you may not have seen this before. Don't worry, it's simple and easy to learn, which is exactly what we're about to help you do. So, some examples of geometric notation. What is it? So, for example, oh, this is cool. Sorry, the whiteboards are new. So let's say you have 2 points, right? A and B. Wow, that's messed up. A and B. And you draw a line through them. And the line goes on to infinity, right? The way you'd represent that geometrically is you draw a line over this AB and you draw 2 arrow thingies. And please excuse this, for some reason the mouse isn't lining up with the thing, so it's really tough to draw. Also, I'm using a trackpad. But that's how you draw a line AB. Now, if you're drawing a line segment where it would just, so there's A, there's B, and it just stops at points A and B, then you just go like that. And that's a line segment. Now, if you have a ray, where say this, so this is point B, right? Oh gosh, that's not right. Let me do this. So there's point A, here's point B, right? And oh wow, and you go, and it keeps going through point B forever in one direction, which is a ray. You would describe it as ray AB, and you draw the arrow whichever way it goes. So for example, if it was going in this direction through point A, then you would draw the arrow going, you'd switch A and B and go BA with an arrow. So that's that. Here's a PDF, dude. One sec.
It's in the Facebook.
Yeah. I normally just teach from that.
Oh, and SP Volunteer.
Where?
SP Volunteer.
I see it.
It's pretty open. You have to keep going.
I know, it's not letting me scroll. Oh, there we go. There we go.
Just give it a second to load.
One sec, let me check if we have viewers or not.
I have 1 viewer.
That's us, we're fine.
That's us?
Yeah, that's us.
Lamau.
We're fine.
Okay. Okay. So we just went over some simple geometric notation, and we just talked about rays. So the next part is about angles and moving into specific shapes. So the way that you convey that you're talking about the measure of an angle, so like about a 90 degree, the measure of the angles, or 90 degree angle, the measure of the angle would be 90. The way that I would convey that is with an M and then this little triangle thing that looks like an angle, and then the 3 points on the angle. And the thing you want to make sure of is that the angle, or the point where the vertex is the same letter that you use in the very middle. So let's go over here. So let's say that I have an angle like this, and I know that this angle is named A, B. Oh wow,
See, it's
that is
autistic.
really bad. Okay,
We don't have yours.
angle, and then A, B,
One sec, let me see this.
C.
Let me see this. We still don't have a viewer. No, just if
I
there's
don't
no.
they can watch it later.
Really?
Oh,
I don't think
it gets saved and then watch it later.
Really? Yeah. Interesting.
Okay, so basically you have these 3 letters that tell you what the angle is called. So basically you always put the middle letter on the vertex. So that's B. And then, you know, this angle could be A, B, C, or it could be switched, and this could be A and this could be C. So that's the gist of angles. And then basically, if you see a little triangle next to 3 letters, that means that the triangle has vertices at those points, or with those points. So that's pretty self-explanatory. And then this shape right here means that it is a quadrilateral. So like anything with 4 sides, so parallelogram or rectangle or etc. So you have that, and then these 4 letters indicate what the vertices are. And they have to be in the same order. So you can't have like A and then, so if I have a triangle, or if I have a rectangle, that rectangle ABCD, I can't have a vertices that's like A and then B and then C and then D. That's not possible. I have to have C be here and D be here, because it would either be going in a counterclockwise direction or in a clockwise direction. That's the only way that it'll work. And then this symbol right here that looks like an upside down T means that the 2 line segments are perpendicular to each other. So being perpendicular just means that you have 2 lines like that and they intersect at a right angle. And we're going to be using squares to represent right angles. And a right angle just has 90 degrees. So that's pretty self-explanatory.
Alrighty, let's talk about points and lines. A unique line can be created by connecting any 2 points. So pretty much if you just have 2 points, like for example, the bullet point here and the bullet point here, there's only one line that can be created if you draw through those 2 points. No matter how you do it, you can't get a straight line that goes through these points other than that one. Between any 2 points on a line, there's a midpoint that is halfway between the 2 points. Pretty self-explanatory. If you have 2 points, then there's somewhere on that line, there's a single point where the distance from one point to that point is equivalent to the distance of the other point to that point. Any 3 or more points may or may not fall on the same line. If they do, then that we say that the points are collinear. So for example, these 3 points right here, you can draw a line between them, right? So they would be considered collinear. Now, if this one was shifted to the left a little bit or to the right a little bit, then you wouldn't be able to draw a line between them. So you would say they're non-collinear. Let's talk about angles in the plane now. To measure how wide or big an angle is, we use a unit called degrees. This symbol stands for a 45-degree angle, which is this is a roughly 45-degree angle. This symbol is a 90-degree angle, which is also called a right angle. So for example, that's the angle you'd see in a square or a rectangle. This flat line here is a 180-degree angle, which is the same thing as a straight line. Supplementary angles are 2 angles that add up to 180 degrees. So for example, let's go over here. So if we have, so here, these 2 angles right here and right here, would add up to 180 degrees because together they add up to make a straight line, correct? So you would say they're supplementary. If instead they added up to 90 degrees, like so, sorry, that's bent, but you can get the gist. If they add up to 90 degrees here, these two angles and these angles right here are considered complementary. When two lines intersect, angles opposite of each other are equal in measure. So you see these two lines are intersecting here. So angle A and angle B are equal. You want to go over triangles?
Okay. So triangles are pretty common shapes, I guess. You should be familiar with them already, and if you're not, I guess we're going to go over them right now. So any triangle has 3 angles in it, and each of these 3 angles has to add up, or all 3 of these angles have to add up to equal 180 degrees. So if you have like a problem where you have 2 angles and you have to find the third, you could do something like 180 minus those 2 angles, and that would give you the third angle. So in any triangle, the longest side is always opposite of the biggest angle, and the shortest side is always opposite of the smallest angle. So it's pretty self-explanatory. So if I had a triangle that's sort of like that, this side is really short because this is the smallest angle. But then if you look here, this side right here is the longest side because it has the longest angle. So like even when you draw these out, it's pretty easy to tell. And then an equilateral triangle is a special type of triangle where all the sides are the same length because all the angles are the same. And they're all 60 degrees because, 180 divided by 3 gives you 60. Okay, next. So an isosceles triangle has 2 of the 3 sides that are the same length, and then one side is different. So when we go back, let's draw an isosceles triangle. So let's call this an isosceles triangle. So we know that this angle and this angle are the same. And because of that, and because of the theorem we just talked about how angle measures get larger with an increasing, or how side lengths get larger with an increasing angle, because these 2 angles are the same, we know that these 2 sides are the same length as well. And we can't say that for this side because this angle is different from these 2. Okay, right triangles. So a right triangle is a triangle that has one 90-degree angle as one of its 3 angles, and it's usually, or the right triangle, the angle or the line that is opposite the 90-degree angle is always the hypotenuse in right triangles. So there are some special right triangles. So if you have an angle measure, or if you have a 90-degree angle, and then you have 2 others, or the other 2 angles are both 45 degrees each, that would make this a right isosceles triangle because both of these sides are the same because both of these angles are the same. And then this is a special triangle because whenever you have a 45, 45, 90 triangle, you always have both legs equaling 1 and then the hypotenuse equaling square root of 2. And this is a ratio that you can use for like multiple triangles. So if I had a problem where I was given that these angles were 45 degrees and this angle was 90 and this was 2 and this was 2, I would know that the hypotenuse is 2 square roots of 2 because of this ratio. Okay. Next. So in a 1 square root of 3, 2 triangle, specifically you would have the smallest angle is 30 degrees, the medium angle is 60 degrees, and then the angle opposite the hypotenuse is again 90 degrees. So it's basically the same concept, except the ratio is a bit different, where the smallest side is just 1, the hypotenuse is twice the smallest side, and then the other leg is the smallest side times the square root of 3. All right, last one is the Pythagorean theorem. This is pretty simple. If you take the length of both legs and then you square each leg, the length of each leg, and add them together, you will get the square of the hypotenuse, which is pretty important. So let's say that I have a triangle. Let's say that I have a triangle like that. Or wait, right triangle. My bad. Oh yeah, this only works for right triangles, by the way. So let's say I have a right triangle and then this is 5, or let's say this is, that's really annoying. Okay, right triangle, this is 3, this is 4. So I can use the Pythagorean theorem to figure this out. So this length would be A, and then this length would be B. So this length has to be C, right? So Pythagorean theorem tells us A squared plus B squared equals C squared. So 3 squared gives us 9. 4 squared gives us 16. And then when we add those two together, we get 20. Oh my gosh. All right, that's 25. And then when we square root it, because remember this gives us c squared, we have to square root it to find the value of the hypotenuse. So we square root 25 and then we get 5. All right, go ahead.
Cool. Let's talk about Pythagorean triples. They're just pretty much numbers which would fit the Pythagorean formula we just learned, right? So for example, 3, 4, 5 fits, so that would mean it's a Pythagorean triple. Same thing for 1, 1, root 2, 1, root 3, 2, and 5, 12, 13. It really helps to memorize these on the SAT, so you can have them just in case a problem involves them without having to think about them and do the math. So all multiples of Pythagorean triples are also Pythagorean triples. So if we multiply 3, 4, 5, we multiply everything there by 2 and got 6, 8, 10, that's also a Pythagorean triple, and it works in the Pythagorean formula. Two triangles are similar if they all have the same angle measurements for each corresponding angle. So that's pretty simple. If you just have two. So these two triangles are different sizes, but if you can prove that these, the three angles are the same to each other, you can prove that they are similar triangles. The formula for a right triangle is base times height divided by 2, and it's provided at the front of every SAT math section. However, again, I recommend memorizing it in most of these geometric formulas, because while it is provided in the beginning of the SAT math section, it takes a lot of extra time to flip pages, and it's a lot easier if you just know it by heart, so you can work with it right off the bat. In every triangle, the length of each side must be less than the sum of the lengths of the other sides. So for example, here, if this leg was 2 and this leg was 3, well, this hypotenuse here has to be less than 5, because if it were greater than 5, then actually what happened is the triangle wouldn't be able to close. You'd end up with 3 lines that don't form a closed polygon. So the length of this has to be less than the sum of these, which is 5. Let's talk about quadrilaterals. Parallelogram is a 4-sided figure with both pairs of opposite sides are parallel to each other. So this would be a good example of a parallelogram. See, this side is parallel to this side, and this side is parallel to that side. In a parallelogram, opposite angles are equal to each other, and the measures of all angles added up equal 360. So opposite angles are equal to each other, as you can see. And if you add these up, these are 4 90-degree angles, so 4 times 90 is equal to 360. This works for any parallelogram, not just this particular rectangle, though. Which goes to my next point. Rectangles are special parallelograms which have 90-degree angles, as you can see. In a rectangle, if you know the lengths of the sides, then you can figure out the length of the diagonal using the Pythagorean theorem. So pretty much you'd square the length of you'd square the width, and then you'd square the length and add them together. Take the square root and you get the diameter, which is just the Pythagorean theorem again. Geometry calculations.
Okay. So the perimeter is the sum of the lengths of the polygon or shaped sides. So that's pretty self-explanatory. So, you know, the perimeter of this is just the length of these 3 sides if you add them together, and then the same goes for like a square. The perimeter is the sum of the 4 sides. And then it's a little different for a circle because it doesn't have sides exactly. So we have a different formula to calculate the circumference, which is the perimeter of the circle. So to find the perimeter of a non-circular object, you just add up the lengths of the sides. But for a circle, it works a little differently. So the formula we use for circumference is 2 pi r. And r stands for the radius, which is the length from the center point of the circle to the outside. So that gives you r. And then d stands for diameter, and diameter is just 2 times the radius. So you do 2 pi r. So that would be the diameter, which is this line right here, times pi. Okay. So the sum of the angle measures of any polygon can be determined with a simple formula, where s is the number of sides of the polygon, the sum of the angle measurements is s minus 2 times 180. So this is a really important formula that isn't going to show up on the SAT or on the formula sheet on the SAT. So it's important to know this. So right here is a good example. A square has 4 sides, so the sum of its angle measurements can be given by 4 minus 2 times 180, which is equal to 360. And this works for other shapes as well. So let's say that I have like an octagon and that has 8 sides. So S in this case is 8. So I do S minus 2 times 180. So that's 6 times 180. Or S minus 2. So 8 minus 2 gives me 6 times 180. And then the way you calculated this, 600 plus 480. So that gives me 1080. So a good way to solve more complicated problems, so if you have like a hexagon, is to try to split the shape up into shapes that are easier to use. So let's go over here. Let's say that like one of the problems is like, oh, you have a lawn that looks sort of like this, and you have to figure out the area. Now I can't calculate this just by itself. So what I can do is split this up into a square like that, and then a rectangle like that, and I can calculate the areas of these individually and then add them together. Okay, so area. The area of a two-dimensional figure is the amount of space that the figure covers. So if you think of the side length or the perimeter as a border, the area is everything inside of it. So the area formulas are in the beginning of every math section, so it's easy to look for if you need to reference it, but it's probably better if you don't have to because you can save time. And then the area of a rectangle is just length times width. So if I have a rectangle and it is a 3 by 5 rectangle, I just multiply 3 by 5. We'll call that a 5. I get 15. So that's pretty easy for rectangles. And then circles are a little different. It's just pi r squared. So you take the radius and you just square it and multiply by pi. That's a really bad circle, but let's just go with it. So you have a radius, and that's from the center point all the way to the outside. Let's say it's like a radius of 3. And I need to find the area. So what I do is, because I know the formula is pi r squared, I just square 3, and that gives me 9. And then I add a pi at the end, because that's what the formula says. So that's about it for this class.
We'll be checking for any questions. If you have any, be sure to post them on the Skybound site. That's that. Signing out. Thanks, guys.